Welcome to Mommy's Academy. In this video, I'll be teaching you prime factors. Prime factors. Firstly, we should know what are factors. Factors are numbers that can divide other numbers without a remainder, without having a remainder. For instance, if you say 5 divided by 2, you will have 2 remainder 1. Definitely 2 that divides 5 is not a factor of 5. So let's think about this number on our screen. 10, 20, 30 and 50. Let us find the factors of these numbers. Beginning from 1. 1 is a general factor for all numbers. All numbers from 1. All whole numbers from 1. So 1 is a factor of 10. Yes. Now what other number can divide 10 sequentially without a remainder? Can 2 do? Yes. 10 divided by 2 will give me perfect 5. So no remainder. So 2 is a factor. Is 3 a factor? No. Because 10 divided by 3 will be 3 remainder 1. And we don't want a remainder. 3 is not a factor. 4 is not a factor. 5 is a factor. And then 6 is it? 7 is it? No. 8 is not a factor. 9 is not a factor. So the next factor is 10. Once you are looking for the factors of a number and you start from 1 till you get to that same number, that will be the last factor of that number. So this number, number 10, has only 4 factors. Numbers that can divide it without any remainder. Now, let's take the second one. 20. 1 is a factor. 2 is a factor. 4 is a factor. 3 is not. 5 is a factor. 6 is not a factor. 7 is not. The next is 10. 10 is a factor. And lastly, 20 is a factor. Now, let's check for 30. 1 is a factor. 2 is a factor. 3 is a factor. Is 4 a factor of 30? No, because 4 times 7 is 28 and 4 times 8 is 32. So 4 is not a factor. 5, is it a factor? Yes. 6 is a factor. 7, is it a factor? No. 7 is not a factor. The next factor is 10 and the next is 15 and the last is 30. Now let's check for 50. 1 is a factor. 2 is a factor. 3 is not a factor. 4 is not a factor. But 5 is a factor. 10 is a factor. 25 is the next factor. And lastly, 50 is a factor. Now you need to understand something about this factor. I begin from 1. 1, 2, 5. One thing is, once you arrive at a figure that the preceding one, the one before it, can multiply to give it, then you can start dividing backward. What do I mean by that? The first I wrote was 1, 2, 5. When I got to 5, I noticed that 2 times 5 will definitely give me 10. Then the next figure will be the one that, if it multiplies this one, it will give me 10. So you can see 10 multiplied by 1 gives 10. So once you are calculating the factors, for instance, take for the second one, 1, 2, 4, 5. When I arrived at 5, I realized that 4 times 5, being the closest, multiplies together to get 20, to become 20. Then the next will be that one that if it multiplies with 2, will give me 20, and that's 10. You will see that after that 2, the next that will give me the next of the factor will be the one that if I multiply with 1 will give me 20, and that will be 20. The same thing for 30. 1, 2, 3, 5, 6. When I arrived at 6, I saw that 5 multiplied by 6 will give me 30. Then the next will be the one that if I multiply by 3 will give me 30, and that's 10. So that suggests the next. Then the next will be the one if I multiply by 2 will give me 30, 15, and then lastly 30. So this is how simple you can be able to get the factors of any given number. Don't forget, we are going to prime factor. So what makes a factor to be a prime? The next thing is to know what prime numbers are. Now, prime numbers are numbers that have only 2 factors. Do you now know why you have to learn factors first? Prime numbers are numbers that have only 2 factors, 1 and itself. So the only number that can divide it without a remainder, the only number that can divide any prime number without a remainder is 1 and itself. Let's take an example of some of those numbers, prime numbers. Is 1 a prime number? No. Why? Because it doesn't have two factors. 1 is the only one that can divide 1. So 1 is the only one. Therefore, 1 is not a prime number. So what about 2? What about 2? 2 is a prime number because 1 can divide 2 and then 2 can divide 2 without any remainder. Therefore, 2 is a prime number. What about 3? Yes, the same is applicable. 1 can divide 3 and just 3 can divide 3 without remainder. Any other number cannot divide it. So 3 is also a prime number. What about 4? 4 is not a prime number because 1 can divide it, 2 can divide it, 4 can divide it. Therefore, 4 is not a prime number. So we have 2, 3, 5, 7, 11, 13, 17, 19. All these are prime numbers. Only 1 and itself can divide it without remainder. So what are now prime factors? So we've learned factors, we've learned prime numbers. So what are prime factors now? So we should be able to take note of that. What are prime factors? So we should be able to tell that prime factors are numbers that are prime and can divide another number without remainder. It's as if we are talking about factors of factors. Factors of factors. So when we talk about prime number, remember that we first said prime number is the number that have two factors. So these two factors, that particular number now, that has only two factors, must be a number that can divide another number without a remainder before we can consider it as a prime factor. So let's take some example. Let's say we need to find the prime factors of 28. Example, e.g., find the prime factors of 28. So to find the prime factors of 28, let's make it simpler by, firstly, let's find the factors. What are the factors of 28? 1, 2 is 3. 3 times 8 is 24. So 3 is not. What about 4? Yes, 4 is a factor. Then 7. You know that 4 times 7 is 28. Then you know the next thing will be 14. Multiply by 2. And the next will be 28. So these are the factors of 28. Now, which of these factors now is prime, is a prime number? So remember, we'll now take PF. PF is prime factor. PF is prime factor. So remember, 1 is not a prime factor. Why? Because it doesn't have two factors. It only has one factor. 1 is the only one that can divide 1 without any remainder. So let's continue to pick 2. Is 2 a prime factor? Yes, 2 is a prime factor. Is 4 a prime factor? No. 7 is a prime factor, and that's also 2 and 7 are the only prime